Hi everyone, and welcome back to the Science, Data and Analytics track. Next up, we've got Gala talking about geospatial data analysis is exploding head. Gala is the head of analytics at Neighborlytics, a startup in the urban tech space trying to help those in the city-making space to deliver better economic and social values in communities. She is passionate about elevating the voice of those who are marginalized and spends her free time reading and ranting about intersectional feminists, questioning and planting seeds of thought into those helping maintain the status quo and trying to be an overall more empathetic and better human. Take it away, Gala.
Thank you. Hi, my name is Gala, and I am the head of analytics at Neighborlytics. And today I'm basically going to be talking about geospatial data. So how this talk is going to happen, I basically have what I call snacks, which are just kind of thoughts and comments on things that are good to know and kind of go back to sometimes. Then I'm going to have a little pantry slide, a couple of slides about stuff to use for like within Python. And then I'm going to talk about for dinner what things I'm excited about. And I guess I mostly want to say that this talk is inspired as a way to kind of brain dump things that I have learned while working in this space, but not necessarily as a way to tell you what to do. So it's mostly snacks and then a little bit of pantry and dinner. So I'll start this talk by stating that working with geospatial data is really hard. And that doesn't mean you shouldn't do it, but it means you should have empathy with yourself when you're attempting all of these problems. I have found it particularly hard to get into geospatial data, and some of the reasons around that is that it's really hard to get started because there's, unlike kind of when you start with Python, with geospatial data, that it's kind of, there's a lot you need to learn in order to get started. It's also a really messy setup, and it tends to be OS dependent, and when you use software, the software is really big and clunky, and so it can really slow down your computer, and so obviously that makes it hard to just play around. And sometimes there's a lot of computation that seems like it should be simple, and then all of a sudden it becomes really hard. And so as I go through this talk, the main point of this is like, here's all these things that I have heard about and maybe learned a little bit about that is good for you to kind of have there as something to go back to. And the aim is to share the slides afterwards, which have a lot of links and stuff. So let's start with some snacks. Okay, so I'm mostly going to be focusing on vector data. There's another type of data in geospatial called raster data, which tends to be about images and stuff like that. But I mostly play in the vector data space. And the way I think about vector data is we have these points, we have these lines, or we have these polygons. So in real life, it's like where I am, a path that I'm walking, or maybe an area that I'm interested in or occupying. And when I talk about these, the ways that I want to have like a mental model about it is with a point, I like to think about it as a tuple or a list of size 2 or 3. So you can have X, Y, and Z. You can have a height dimension, like for example, if you're standing at the top of a building. And one of the things that's interesting about points that's good to think about is the fact that mostly in geospatial, you'll get latitude and longitude. But if you come from a math background, you're used to X, Y. And this is opposite. So that's something to think about. A line string, one of the things that's interesting about the line string is that the order matters. And so you basically want to think about it as Google Maps directions. So here's a stopping point, then you walk in this direction for this long, and then another stopping point. And so the order matters in the line. And in the polygon, you want to think about it as a closed loop, and it kind of includes all of the area inside of that. And it can be a donut, but yeah, you know, it's good to think about it as a big closed loop with everything inside included. And I just want to say all of these things depend on what file system you're working on, and so they're not always true. Within this like stuff that we have, points, lines, and polygons, in geospatial we also encounter things like multi-line and multi-polygon. And why this is really messed up is because you can have a set of polygons, kind of, if you think about it as a CSV, you can have different rows where each row is a polygon. But a multi-polygon would actually define lots of polygons within the same row. And a good example of this is, for example, Tasmania. If I look at the polygon that is Tasmania, it's actually separated polygons, but it's all of it is Tasmania. So if I was, for example, to get a file that had data of Australia, Tasmania might all appear all in one row. And that can create lots of problems when you're working with geospatial data. So it's something to think about. There's also this thing called complex geometries. And if you look at this center polygon here, one of the things you see, there's like a bit of a shaded gray line. And so if you think about what we talked about in the line as order, you can start kind of thinking about the fact that if I follow these points in a weird order, I can actually cross my polygon and then cross it back. And that can actually create lots and lots of problems. And so a good thing to think about and note is this concept of complex geometries, which means basically it's not a simple geometry. And a simple geometry is one that is doesn't have any of these quirks to it. That's something I didn't learn about until like quite far into being in geospatial data, and it's a really it's a cause of lots of pain. Yeah, so one of the biggest issues with geospatial data is that the Earth is not flat. And so when you have some geospatial data, it comes with what we call a spatial reference system, which is the same thing as a coordinate reference system. And I guess the way I think about this is like my data has some values, so I can see some numbers, and then I need to know how to interpret those values when I look at them in the context of the Earth. So these kind of spatial reference systems or coordinate reference systems, you kind of want to think about, they have two parts. They have a coordinate system, which tells you how a particular coordinate is defined. So think X and Y or a lat long, or maybe it's an angle and a radius. And then you have a datum. And the datum specifies where the center of this coordinate system is, and the scale, and also the orientation. And there's lots of datums out there, just like there's lots of coordinate reference systems out there. And in particular in the industry, we like to use these EPSG codes to kind of grab predefined ones. And these are also sometimes referred to as SRIDs. And I wouldn't even know the technical difference between these. I believe the SRIDs, there's more of them than the EPSG codes, but the main point is like, these are words you want to look up when you're thinking about your coordinate reference system. And this picture that you see here on the right is actually one that I find really interesting because, so in Australia, as you can see in this picture, is that because due to plate tectonic motion, Australia has actually shifted. And so before we used to use this datum called GDA 94, but now we're going into GDA 2020. And in particular, this new datum will have like places will be 1.8 meters to the northeast of the GDA 94. And like, this is nuts, right? We never think about how these things are changing kind of right underneath us. And so it shows you just how important it is that you know very clearly what your coordinate reference system is. Okay, so these EPSG codes. Maybe something that I learned really late and that I would like for you to know if you haven't done this stuff before is, if you're given a file and it has latitudes and longitudes and you're like, what's the CRS, what do I do? It's like, a good one to start with is this one we call EPSG 4326. Now the coordinate system here is latitudes and longitudes, and it's in degrees. So when you move, you're actually in degrees. And the datum is what we call WGS 84. And this is basically like telling you that you're going to be using these latitudes and longitudes. And it kind of defines as you move. And one of the things that's interesting about this is that because this coordinate reference system is in degrees, when you want to measure something, the measurements will come back to you in degrees, which is a really messed up thing to think about because, well, at least when I started geospatial data, all I want to think about is how far things are in meters. And I didn't even realize that there was kind of a way to think about how far things are from me in the kind of degree space. That was something that really tripped me up. So most kind of proper geospatial files will come with one. So for example, in shapefile, which is something that comes from Esri. There'll be actually lots of kind of files. It's a bit of a package of files, and one of them contains this information. But some of them simply just have it defined somewhere in text, for example. So the Earth is round. We need to flatten it because we want to start measuring things in meters. And so that brings us to projections, which, oh no, the video's not playing. It's coming. Yes, okay. So projections is basically how we try and make something round, flat. And I say round, but really the Earth is not even exactly round. So that's how complicated this stuff can get. And so when we make these things flat, we have to optimize for a particular thing. So we might want to, and that depends what you're interested in. And so if I'm measuring distance, I want to optimize for things that are going to kind of be accurate in the distance perspective. And what's interesting about this is we actually call that a transformation. And this is good to know because when you're kind of Googling, the word to look for is how to do a transformation. And basically what you're doing is you're going from one CRS that is not flat to one CRS that is flat or projected. A good way to kind of know what space you're playing in is to look at the units of your CRS. If it's in meters, you're probably in a good spot. If it's in things like degrees, probably in a bad spot. And there's local ones. So as I mentioned earlier, in Australia, we like to use this GDA 2020 nowadays. And so that's going to let you be very precise within kind of the Australian area. And there's actually some defined down to like Victoria and down to New South Wales because clearly Australia is really large. So I find projections to be the coolest, but they're also the biggest source of pain whenever things aren't working for me. All right, so WellknownText. Someone decided to do this text markup language, which was great because now it's like, this is how we define geometries in pure text. And this is really nice because in particular, lots of different libraries and lots of different places will accept WellknownText and then turn it into their own thing that they define and stuff. So WellknownText is like total lifesaver. I really recommend you kind of keep it in your back pocket, little chocolate snack. Cool, so a pantry. Let's get into some of the more kind of heavy Python stuff. And I say heavy, but there's really not that much. So I guess I just kind of want to take a little bit of time to talk about all the different libraries that I use in it every day. It doesn't mean that these are the only ones. There's so many out there, but these ones are quite generally used. And so Shapely is a library that lets you kind of quite easily, particularly with the WellknownText thing, just define and draw geometries quite easily, particularly if you're in a Jupyter notebook. If, for example, one of the coolest things is you can make a geometry and you can just print it, and it actually shows you the shape. So if you make a little polygon, you can actually see its shape. So it's a really nice place to start, Shapely, but it's a bit, sometimes it can be a bit just kind of, at least for me, I use it quite elementarily, like to define a point or to define a line. Now, GeoPy I like. GeoPy lets you do simple calculations like distance, and it lets you, for example, you can calculate distances understanding the world as perfectly round or understanding the world as an ellipsoid. And so it really lets you play around with, well, what happens when I don't think of the Earth as exactly spherical or whatever. GeoPandas is, as its name suggests, it's just like pandas, but it has this geo component, and so it can understand each row as a geometry. And you can also give it your CRS, and so it can understand that, you know, things that you're playing around in, but it can also do stuff like find me the distance to all of these places, or find me all of my rows that are within this polygon. And so it can be quite useful to do, like, actually quite a bit of stuff. I really like the GeoJSON package. So GeoJSON is it's a JSON defined, but it has geometries. And so it's actually a really nice way to pass data around without it ever getting corrupted and to kind of not be specific about a particular software. And I like it because when you read or write with this library called GeoJSON, it will check whether it's valid GeoJSON. because you will be shocked to know that lots of libraries can write GeoJSON-like text, but then it's not valid GeoJSON. And that is part of the problem in the industry. GeoAlchemy is something that I use with SQL Alchemy, which is an ORM. And I use this particularly when interacting with Postgres database that has this PostGIS add-on, which it's basically a Postgres database that lets you have geometries. H3 is this picture that you see here on the right. Oh, sorry. Oh, where did I go? And it's actually posted by Uber, but it kind of has gridded the entire world into these little hexagons, and they're tilings, which means there's no space in between them. So it's a really nice way to understand areas. And then for plotting, I usually use Plotly or Discartes, but I really want to say that pgadmin, for example, lets you, when you're using Postgres, it will actually plot things for you. So it's a really useful tool that I learned recently. All right, so for analysis and algorithms, the kind of newest ones are PyCal and MonPy. I actually haven't played much with these, but I mean, I was literally looking at their websites yesterday and thinking, how many days do I need to take off work so I can start playing with these? And they're actually quite new and advanced, and they kind of propose a lot of new algorithms that before have been a bit kind of not very easily to get to from the geospatial side. All right, so the community. On the right here, I put some Slack channels that I usually am playing around in and some Twitter stuff that I follow. But I guess from the community, I want to say is like, it's very dude and white heavy. And that can make it really hard to interact in. And I guess the one main comment I want to make is that the geospatial community, a lot of the people come from other fields. And so they all have very kind of impressive knowledge in one particular area, but then they'll have like no knowledge on this other area. And so one of the things that you get in the forums is like, you just want to ask a really simple question. And the next thing you know, you have these like massive amount of text coming back at you with so much jargon and so much information that it can almost feel like it's not accessible. And so that is something to be very conscious about, that it's not you. You're coming into this community of people who are kind of really deep into some particular knowledge. And yeah, like I have found it to be really hard, but the more I kind of stay in the same communities, the more you realize that this entire lump of text is what everybody gets, because this is a problem that everybody has. Even from like installing geospatial stuff on your computer. So I guess what I'm saying is take it slowly and kind of don't shy away too fast from the community. And it is changing. The Women in Geospatial has made a big noise to kind of bring more women, or at least highlight the women that are in geospatial. All right, so one of my main slides is around debugging. So here's some thoughts, which is basically like, things are going wrong. Good things to do. Check your CRS. Are you in the right CRS and the one you want to be? Do you even understand it? Check your geometries. There's this thing you can do, which is called simplifying your geometries. It basically means, do you really need all of these vertices? Could you make it a bit simpler and have the exact same shape? If you're having lots of issues, sometimes your geometry being a multi-geometry can make problems. Check that the lat long is actually what I guess the right way around, because lots of places want to define it as x comma y, and that's fine, but you just need to make sure that you have kind of that knowledge when you start trying to compute things. Plot something always, put a map behind it, don't just look at its shape. Make sure it's not in the middle of the ocean when you plot it against the map. Be careful with hidden stuff that's overlapping. Sometimes when you do plot it, you'll see one point right on top of the other. And so you'll actually think it's just 1 point. Why am I seeing 5 in my data? And so one of the tools people use for this is to try and do jittering so that you can actually see all the things there. A lot of times you go and plot stuff and you get absolutely nothing. I think this has to do with like error checking, like people giving good error messages in the libraries, but nothing usually means there's an error, not that you have nothing. I really like opening the file in some sort of software, so I tend to use QGIS. But as I mentioned before, pgadmin shows you geometries, so it's actually a really nice place to go look. Make sure you read the docs. Just literally a week ago, I had this frantic moment thinking about geometry versus a geography. So make sure you understand what the different things mean. By the way, a geography means you're kind of in the lat-long space, and a geometry can mean anything, including something that is flat. And invest in learning how to use the library. Lots of the libraries have some sandboxes and stuff, so make sure you take some time to kind of look in there. All right, so some things I'm excited about, and I kind of skip through these a little bit fast to make sure there's room for questions, but I'm in the urban planning space, so this city-to-city translating is actually really cool, which it basically says, it kind of tries to take from natural language processing and say, if I give this data and I put it in a common vector space, then can I find two things that are similar via their vector space representation? So that's a really out there and cool idea, because it means we could find similar neighborhoods or similar cities across the world. Another thing that I really liked was this person who kind of took all the OpenStreetMap data and started kind of plotting it in ways that were kind of talking about its form from the urban side. And in particular, it shows here, they analyze basically our streets pointing north, east, south, or west, and how many of them. And so the ones that look exactly like crosses tend to be really gridded cities, or they actually are really gridded cities. And then you can see other ones like on the top right corner where it's like, it just looks like a filled up circle, which means streets are nuts. They're going all over the place. Cool. And the last thing I want to say, I mentioned this before, but this MOMPy is a library for quantitative analysis of urban form. And what it's doing is it has all of these really cool algorithms to try and understand space and kind of places around them, and yeah, it's kind of pre-coded a bunch of the algorithms that are used in the industry. So I'm really excited about them. So that's it for me. I just want to say that we are hiring, so please find me somewhere in the chats to talk to me about that. And yeah, thanks for listening. Sorry that was a bit of a ramble, but had a lot to share.
Thanks, Gala. That was a really great talk. Quite a few things that I wish I actually knew 2 or 3 weeks ago now. We have a few questions in the chat.
Okay, I'll try.
One from Jeff. Why work with a projection? Why not just try and answer your questions like how far between A and B without a projection, and only use a projection when you want to visualize things for users?
Yeah, I mean, why not? When you're playing in the kind of, I'm in round space, like when you're on the sphere, sometimes a lot of this computation becomes math heavy, right? And so when you kind of go to do things flat, you can then do lots of them really fast. So, I mean, like, as I said, I'm not telling you what to do in this talk. I think part of it is mostly like, know about projections. I find it really hard to think about, maybe I'm just a local thinker. And so when I think about standing on the beach, I kind of think about how flat everything looks around me, but clearly have an understanding that if I go far enough, it's round and I have to start considering the roundness. So I like playing in a space where I can check things. And so flatness lets you do that. I mean, obviously roundness lets you do that, but in flatness, there's a little bit more of intuition I can grab from previous experience, whereas in roundness, that all becomes a bit harder. So maybe as a way to start, it's nice to be flat. But yeah, I mean, there's lots of stuff to be said around staying in the kind of spherical space.
Thanks, Gala. And just one more quick question before we run out of time. Any tool recommendation from Prashanth? Sorry about my pronunciation. Any tool recommendations for looking at raw data straight out of CSVs before we start working with it?
You know what? I mean, I really like QGIS because you can just kind of drop it, tell it where's the lat, where's the lon, and then it just plots it. So I guess in that sense, I am a sucker for, like, if you just want to get something fast to just look at it, doing that like with Python, it does kind of take some knowledge and a little bit of setting up. Now, with that said, as you work with this data for a while, you kind of start developing all kinds of kind of functions that you build up that you're like, this lets me plot something fast. But I liked starting with QGIS because you literally can just drag a file in and then you can see it. And you can just put a map behind it really easily. So I know that doesn't sound so coder obsessed, but it's true. Like I really like using the software.
Cool. Oh, thanks for that excellent introduction, Gala. We're at time now, so we're going to have a 10-minute break, and then we're going to come back for to hear about the software engineering part of data science. Everyone else, applause, and I'm sure Gala will be around for the rest of PyCon. So try and find her in venue lists and ask some more questions if you have any. Oh, see everyone in 10 minutes.
See you later.